The digital world moves at a blinding pace. Everywhere we look, systems are automating, algorithms are generating, and the machinery of modern life seems to be running on an intelligence we cannot see. That speed breeds a specific kind of anxiety, the quiet fear that human minds are becoming obsolete. If you approach this from the outside, the barrier looks insurmountable. We tell ourselves that because we don't speak the language of advanced calculus or software engineering, we are locked out. When a machine appears to think, we assume it is operating on a level of magic reserved for the technically elite. But if we step back, the foundation of all intelligence is much simpler. Imagine a cook tasting a new soup. The cook doesn't need to calculate the molecular structure of the salt. They simply notice a pattern from experience. Too much salt overwhelms sweetness. Acid lifts a flat flavor. Artificial intelligence is not a magical entity. It is a highly structured, mechanical mirror of that exact human ability. It reviews examples and notices statistical relationships. It learns which ingredients, or data points, tend to appear together. The intimidation we feel comes from misunderstanding the tool. Whether we are looking at a human brain or a neural network, intelligence at its root is simply structured observation. To remove that intimidation, author and educator Ravindra Nayak built a comprehensive knowledge universe. His work relies entirely on a method called first principles thinking. Through series like The Algorithm of Life and the AI Mathematics Ladder, the complex world of modern technology is translated into an approachable, step-by-step path for the non-technical reader. First principles thinking is the practice of breaking an idea down to its working bones. It strips away the jargon and the hype until you find the basic logic that allows the system to operate. This approach is not new. It is the same structural logic ancient philosophers used to establish the early foundations of reasoning and causality. They understood that every valid conclusion requires a firm, simple starting point. Later physicists adopted this exact mindset to understand the physical world. They proved that true mastery of a subject means you can explain it simply, removing the noise to reveal the underlying mechanics. Modern psychologists applied it to the architecture of human decision-making. They mapped how our judgment actually works, providing the link between abstract theory and how we make choices under pressure. Before we can demystify how machines learn, we must master the logic of how we think. We have to build the mind before we build the machine. This raises a natural question. If a machine lacks consciousness and can only process raw numbers, how can it possibly understand the meaning of a word, an image, or a human request? This page shows why numbers matter. Numbers allow comparison. We use them to measure and represent reality precisely. Converting the real world into numbers is the first quiet step toward machine intelligence. Once numbered, we organize the world. This text illustrates turning words into vectors, coordinates mapped into a structured space. The system calculates relational patterns, noticing the distance between man and king equals woman and queen. It isn't reading grammar, it's reading geometry. When concepts are related in human language, their coordinates end up closer together in this mathematical space. The physical distance between data points literally becomes semantic similarity for the machine. This diagram of the learning pipeline shows the whole process. Raw input data enters on the left and converts into mathematical scores. Moving right, that score dictates the final decision. Finally, the system receives feedback, adjusting its internal math to perform better next time. An AI model does not have a conscious mind. It does not feel or comprehend. It calculates meaning using geometry, tracing the distances across a highly structured pipeline. What happens when the machine's geometric guess is incorrect? What occurs when it fails to recognize the right pattern? AI systems use a loss function to track errors. The machine calculates how far its guess was from the correct answer, then adjusts to find the path of least resistance, rolling down the gradient until it reaches the lowest possible point of error. The machine possesses a massive advantage here, mechanical indifference. It does not feel shame when it is wrong. Humans, however, carry ego. We often let fear or pride block our ability to look at our own errors, treating a mistake as a sign of weakness rather than a signal for course correction. This page outlines feedback without collapse, framing optimization as a human repair loop, where a gap isn't a verdict. The lower section shows EQ asking what happens inside, while IQ asks what is true. Integrating both creates humility, keeping evidence of mistakes visible. True intelligence, whether artificial or human, requires a specific discipline. It is the ability to treat a mistake purely as a data point for the next iteration. We can now synthesize exactly what the machine is capable of doing. AI to scale similarity. It can process vast vectors of information and output probabilities flawlessly, but it remains completely blind to purpose. This creates a clear boundary. The AI model serves as a recognition engine, surfacing statistical relationships within the data. The human being remains the primary authority responsible for the outcome. An algorithm will always find the most mathematically efficient path to a goal, but efficiency is not wisdom. Human conscience, empathy, and ethics are required to define the boundaries of the system and decide if the output is actually useful. This reveals that mathematics, psychology, artificial intelligence, and philosophy are not isolated subjects. They are one unified, interconnected ecosystem, built on the exact same first principles. Once you see this structure, the intimidation fades. The question shifts from worrying about obsolescence to asking where to begin building your own architectural control over these tools. To start that journey, explore Ravindra Nayak's books or follow our upcoming series here. We will break down this knowledge universe step by step from the ground up. The future does not belong to those who fear the machine. It belongs to those who master the human algorithms required to lead it.